Hello and welcome to lesson 94. We are going to be looking at two-step word problems. All that really means is that the solving of the particular problem is going to involve maybe two particular strategies or two steps in the process. So we're going to do one thing and then maybe use that information to follow up with a second step, and then therefore get the right answer of the two-step problem. Make sure that you are showing your work. I'm encouraging you to show your work, show the steps, because as math problems get more and more complicated, it's very important for you to detail your steps and detail what you're thinking and the process that you're using so that you avoid confusion. Okay? All right, so you've already done the warm-up problems, and if you're watching this video, you want a little information about the new concept. It says here we have practiced two-step word problems that involved finding total costs. That means including tax, okay, total cost of something, and the change back. So those are kind of your two steps, the total cost and the change back. Step one, step two. Starting with this lesson, we will practice other kinds of two-step word problems. Writing down the given information or drawing a picture is often helpful in solving these problems. So you have to take the time. Don't try to do everything in your head. Don't try to work through everything mentally. Instead, write something down. Take the split second that it takes to write it down, write down the information, and then maybe draw a picture as is recommended, so that then will help you and lead you and guide you into finding the correct solution. Okay? And you may read the problem and not know how to solve it. That's why we first gather information. Gather information, and then that gathering of information is then hopefully going to nudge you in the right direction as far as what direction you should go to solve the problem. Okay? Here's an example. It says Jim is 5 years older than Ali. Ali is 2 years younger than Blanca. Blanca is 9 years old. How old is Jim? So again, the first thing you might want to do, because there's a lot of words and there's numbers in there, you want to first try to gather that information and organize it and try to make sense of it. So it says here, we're going to use two steps to solve the problem. First, we will use Blanca's age to find Ali's age. Now, it may seem kind of odd, but you notice you're starting here at the end of the word problem. The last bit of information talks about Blanca because you're actually told the age of Blanca. Blanca is 9 years old. That is a specific value that you can work with. And from that, you're then going to move to find the ages of the other two. The other two ages for Ali, it says Ali is 2 years younger. It is related to somebody else's age, 2 years younger than Blanca. And then it says Jim is 5 years older than Ali. Jim's age is related to Ali. Ali's age is related to Blanca, and Blanca is 9. So we got to start with Blanca and then work to Ali and then to Jim. So Blanca is 9 years old. Start with the information that is given. This often in a problem you might see this, given. Blanca is 9 years old. Then you are told, here are some of the unknown values. The unknowns, you don't know Ali's age and you don't know Jim's age, but you do know how they are related to somebody else. So Blanca is 2 years younger, Ali is 2 years younger than Blanca, and Jim is 5 years older than Ali. So let's start here at 9 and use this line of information, this word equation, to help us figure out how old Ali is. Ali is 2 years younger than Blanca. So if Blanca is 9, then of course you're going to subtract 2 and get 7, and that would be Ali's age. Ali is younger than Blanca by 2 years. Then it says Jim is 5 years older than Ali. So now we're going to add 5 onto Ali's age. 7 and 5 is going to give us 12, and that's going to give you Jim. So here was step 1, and then from that information we were able to then go to step 2. Notice we couldn't find out Jim's age until we knew Ali, and we couldn't find Ali's age until we knew Blanca's, whose age was given. Okay? Another example. Carlos paid for 5 pounds of apples with a $10 bill. He got back $6. What was the cost of each pound of apples? So, paid for 5 pounds of apples with a $10 bill. He got back $6. What was the cost of each pound of apples? Notice he bought 5 pounds. Sometimes you have to read the problem more than once, and that's okay. You might have to read it over and over again, and then it starts to make a little more sense for you. No problem with that. Okay? There's no shame in that at all. So, here's the suggestion. Again, start with something that you know, and you're finding out the cost of all 5 pounds of apples. So, he gave the person $10, but it didn't cost $10 because he got back $6. So let's find out the total cost here. Again, Carlos gave the person, the seller of the apples, the vendor, $10, got back $6. So that means he must have paid $4, only $4 for the 5 pounds of apples. Here's step number 1. Now it says, don't stop there. Make sure you are answering the question, because sometimes in a 2-step problem we get sidetracked and we figure, oh, here I got a number, I got an answer, but that's not the answer that it's asking for. You've got to finish the problem and make sure you go all the way through. So now it says we want to find the cost of each pound. This is the cost, $4, for 5 pounds. So we have to take that $4 and divide it into those, or divide it by those 5 pounds. So $4 divided by 5. 5 goes into 4 0 times. Bring down the 4. Bring down the next number, which is a 0. $4 here. There's nothing behind the 4. So with currency, we're going to put 0.00. 4.00. $4.00. So 5 into 40 goes 8 times, and it's very important that you line up the decimal point here, because this is not 8, it's 0.8. And then 5 goes into 40 8 times evenly, so there's no remainder, and you're going to put another 0 at the end because we're talking about currency. So we're talking about how many dollars and cents. So this is actually $0.80, or just 80 cents. Okay? Each pound is 80 cents. Alright, a little practice here. Nancy, I'll just set these up for you. I'm not necessarily going to solve them. I'm going to set them up and then you can finish them. Nancy paid for 4 pounds of peaches with a $5 bill. She got back $3. What was the cost of each pound of peaches? Here's your hint. First, find the cost of 4 pounds of peaches. So they're telling you what step number 1 is. And then from there, we'll go to step number 2. So, find the cost of 4 pounds. 4 pounds was $5. Oh, no it's not. It's not $5 because she got some money back. So it is actually $5 minus 3. She only had to pay $2. But that was for 4 pounds. So now you're going to take those $2, which can be written as 2.00, and divide that by 4 pounds. 4 goes into 2 0 times. Bring that 2 down as well as the next number. 4 goes into 20 5 times. Be aware of the decimal point. Line those decimal points up. And that goes in evenly with no remainder. If I was to bring down the next number, it's a 0. 4 goes in 0 0 times. So that's 50 cents. So each pound is 50 cents for the peaches. The perimeter of this square is 12 inches. Now let's pause for a second. Perimeter, let's just remind ourselves, perimeter means the total distance around. Not just one side, total distance around. And it's a square. Read carefully. Read carefully. A square, we know the square has all 4 sides are equal in length. So what is the area of the square? Well, let's start here at the end, area. Area, to find area, you need, for square, it is side times side. Like a rectangle too, side times side, or length times width we say sometimes. So side times side is going to give you the area, or side squared is how we write it sometimes when two numbers that are the same are multiplied together. S, in this case, S represents side, and the 2 there is representing how many times I'm multiplying it by itself. So area is side times side. So that means I need one side. Well, I'm not given one side. I'm given all four sides together. So find the length of each side. The total distance around the square is 12. I'm going to divide that by 4. 12 divided by 4 is 3. I can do that because each side is identical, so every side is 3. Now to find the area, I'm going to take 3, 1, 2, 3, times 3. And I'm going to find out I've got 9 squares. I didn't draw that very well. 9 squares that fill 9 square inches that fill that box, or that square, I should say. So 3 times 3 is 9. Important to write down the units. This is area, and the unit is inches, so it is inches squared, or square inches. Okay? Robert is 10 years younger than John. We're not told Robert's age, we're just told that he's 10 years younger than John. Okay? Robert's age is related to John. Then John is 2 years older than Jenny. And then it says if Robert is 13 years old. So this time we're given Robert's age. We know Robert's age is 13. And then from Robert, we can find out what John is. And then from John, we can find out what Jenny is. Okay? So here we go. We're told that Robert is 10 years younger than John. Well, Robert is 13. So here's 13. And that is 13 younger. That's 10 younger. That's 10 less than what John is. That means if I was to add 10 to 13, then that would give me John's age. Up here, this was Robert. So since Robert is younger, we're going to add those 10 on to get John's age. And then John is 2 years older than Jenny. So Jenny is younger. So I'm going to take 2 years away from John and get 21, and that would be Jenny. So I've got Robert is the given age, John is 23, Jenny is 21. All right, I hope that's helpful. Go ahead and take some time to work on the mixed practice problem set there. Work through all 30. It's very important. Don't miss a one. Don't skip anything. If you got questions, you got to ask. All right, keep up the good work.